Now in this video we're going to build an AI agent in n8n which has access to two MCP servers. Now first of all we're going to connect our AI agent to a RAG MCP server that we're going to build ourselves. Secondly, we're going to connect our AI agent to an MCP server that has access to a search engine. And this will allow the AI agent to connect to the RAG MCP server when it needs more generic knowledge, and to connect to the Search Engine MCP server when it wants to get information about more current events. Now when I just heard about the MCP protocol, I was a bit skeptical and I was thinking like, how is this really different than calling tools that have access to APIs, for example? And by the way, MCP is not as simple as it looks like, because even in n8n there are 3 different implementations of MCP servers. So before building our AI agent, let me first explain you why this protocol is so valuable, and secondly, what are the different implementations of MCP servers. Now at the end of 2024, Anthropic introduced the MCP protocol, allowing you to connect to an MCP server, which exposes a number of tools. So the agent that we are building today is connected to 2 MCP servers. One of them is a RAG server with a RAG database. The second one has access to Google and can execute Google searches. And you can also see that they are connected via 2 different protocols. So one is connecting via the MCP SSE protocol, and the second one is connected by the MCP STD-IO protocol. Which raises the question, how many different MCP protocols are there and what are the differences? Now n8n has 3 different ways to connect to MCP servers. The first one is the HTTP plus SSE protocol, and this is basically an older protocol. And you can connect with SSE servers with all different versions of n8n, including the cloud-hosted version and a self-hosted version. Now at this moment there is also a newer and better version of MCP available, and this one we call streamable HTTP, and that's the blue box you see here. So both streamable HTTP and HTTP plus SSE are servers that are normally located on the internet. Of course you can also install them on your local PC, but normally you connect to these servers via the internet. They are not locally hosted. So how do they compare to each other? Basically they can do the same, but the streamable HTTP protocol is just better and more efficient. Now the third option is an STD-IO MCP server, and this is an MCP server that is hosted locally on your PC and that is accessed through the command line. So what basically happens, and you will see that in more detail later in this video, is that we send a command to the command line to either a Node.js package or, for example, a Python package. So the STD-IO server is always hosted locally. Now the RAG server that we're going to build in this video is using the SSE protocol, so you can build the first part of this video with either the self-hosted or the cloud-hosted version of n8n. Now the second part of this video, where we connect to the Search Engine MCP server, you can only follow if you have access to the self-hosted version of n8n. If you do not have n8n installed on your computer locally yet, you can get it by watching my other video where I show you how to install n8n locally on my PC. It's entirely free and it only takes about 10 minutes. Now what technical consequences do these 3 protocols have? Now first of all, SSE or streamable HTTP servers are normally hosted on the internet, so they can just use local tools or local APIs if they want to connect it, for example, a database. Now because an STD-IO MCP server is always hosted locally on your PC, it always needs to use an API if it wants to send data or fetch data from a database hosted on the internet. So why is using an MCP server better than just using local tools? Now first of all, because MCP is a standardized framework, and this is rather different than using APIs and SDKs, where every API has its own documentation and its own implementation guidelines. But the most important aspect of the MCP protocol is tool discoverability. So just imagine that an AI agent connects with an MCP server in July 2025. So at that moment, the server exposes 5 tools. The AI agent selects the tool that is the most appropriate at that moment and performs the job. But now imagine that the same agent connects with the same MCP server in December. And at this moment, the MCP server is exposing 20 tools. And having access to all these tools, the AI agent can now select a different tool without the developer of the AI agent having to make any differences to the AI agent. Now honestly, n8n doesn't support this functionality 100% because it supports tool discoverability, but it also lets the developer hardcode the tools that he wants to use on the MCP server. So this story doesn't work 100% if you work with n8n. And then last but not least, just imagine a RAG MCP server where the owner is refreshing the data of the MCP server every day, for example, and 1,000 different agents are connecting to this MCP server, so they do not have to refresh this data locally on their system. So the protocol has many benefits. Let's see how they work in action. So as you can see, I've created a workflow called MCP Server. This is where we are going to create the MCP server. And after building the server, we're going to create another workflow where we are going to build the MCP client. So let's get started. I'm going to start by adding a server trigger. So just search for server, and there you see here MCP server trigger. And this is exactly the server trigger that we need. As you can see, we get a test URL here and a production URL. And later we're going to use this URL to connect the client to the server. For now, I'm just going to click on back to canvas. And as we are building a RAG MCP server, I'm going to add a tool and search for Quadrant Vector Store. This is the one that you need. You want it to connect to the local Quadrant API database. We want to retrieve documents as a tool for an AI agent. Let's give it a description as well. And I'm using this description to tell the AI agent when it has to use this tool. So of course, if you are going to add different documents to the RAG database, of course, then you also have to change this description. And then for the quadrant collection, we're going to select from list. Then we're going to add here, click on expression, MCP_RAG, click on fixed. It doesn't really matter which name you provide here, as long as you provide the same name in the ingestion pipeline. You can here choose the amount of chunks that you want to receive from the document. So in this case, it's 4, but you can also minimize it to 2, or you can expand it to 10, for example. Let's go back to the canvas. And then there is one thing that we still have to add to our MCP server, and that is an embedding model. And I'm using Ollama locally. There is another video on my channel that explains how you can install Ollama locally if you want to use one of the Ollama models. But of course, you can also as well use a ChatGPT model here, for example. But in this case, I'm going to choose for embeddings Ollama. And the model that I'm going to choose here is not a Llama 3.2, but it's the MXB AI Embed Large model, this one. So just select it, and then let's go back to the canvas. Okay, so this is what we have now. I'm just going to zoom out a bit, because this is our entire MCP server. And then there is only one thing that I'm going to add to the MCP server. So just hover over the plus icon and click here. And that's just such a colored box, just to show that this is the MCP server, and the other part of this flow is the RAG ingestion pipeline. So just make it like this, and then I'm just going to give it a description like this, and let's give it as well a different color. So let's make it green, for example. Okay, and then let's add another one, and I'm just going to add this one for the RAG ingestion pipeline. And this workflow we're going to use in order to add documents to our RAG database. And in order to trigger our RAG ingestion pipeline, I'm just going to click here and then search for our form. And then you see here n8n forms, and make sure that you select the form as a trigger. So on new n8n form event, this one, let's give it a title. And then we're going to add some form elements. So add form element, and I want to upload a file. And it has to be of type PDF. PDF file like this. And this is a required field. And that's all we have to do for now for the form. So let's go back. Let's make sure that the form is here. Let's execute it just to see if the form is popping up as expected. So execute workflow. And then you see here that we can choose the file. And we can click on submit, but nothing is happening yet as there are no further actions defined. So let's close this one and let's define those actions. So when someone triggers this form, we want the document that the person adds to be ingested into a RAG database. So just search again for quadrant, and then we're going to need the quadrant vector store, the local activity. So click here and then click on add documents to vector store. We want to work with the local quadrant database. We want to insert documents, and the quadrant collection is exactly the same collection that we have seen before. So just click here on expression, RAG MCP, click on fixed, and the batch size, you can leave this on 200. It doesn't really make a difference for now. Let's go back to the canvas. And then of course we also need an embedding model. So you can add another model here, but what you can do as well is use the model that we've already added here, because what is really important here is that the embedding model on this side is exactly the same embedding model as the model used on this side. So they have to be exactly the same. And this way you can guarantee that the model is exactly the same. And now we need a document loader, so we can just click here, and then we're going to choose for the default data loader, this one. And the only thing that you have to change here is just change the JSON to binary, and the rest you can all leave the same. Okay, and I just realized that I made a very minor mistake, because here we have MCP_RAG, but here we have RAG MCP. So I'm just going to change this one to MCP_RAG like this. And then we've already built our entire MCP server and a RAG ingestion pipeline. So let's click on Save. Let's navigate to the MCP server trigger. Then we're going to take the production URL. You can as well take the test URL if that's what you want. And then let's copy this one back to Canvas. And then if you want to use this MCP server, we have to make this workflow active. Otherwise, we cannot receive calls from the MCP clients. So just click here on active in order to activate this workflow. Now there is only one step that we still have to take before we can start building a client, and that is adding data to our semantic database. So click on form submission, click on execute workflow. The form will pop up. I'm going to pick a file, and the file that I'm going to pick up is this one. And you can download this file from a GitHub. There is a link in the description if you want to use it. Click on submit, and then this form will be added to the semantic database. You'll see that the workflow has now been executed. And if we now navigate to the Quadrant vector database, so if you have used Docker in order to install n8n locally, you can just click on Docker, then click on Quadrant like this, and then you get this, and then you're just going to add /dashboards, and then you see all the collections that have already been created. So we have already created MCP RAG. You can click on it, and you can see that the data has been ingested into the semantic database. Now we have built our MCP server. It's time to build our MCP client. So I created a new workflow which is called MCP client, and here I'm going to add an AI agent. So just click on add first step, search for AI agent, and then we're going to add this AI agent. I'm not going to configure it for now. We're going to do that later. So click on back to Canvas. And the first thing that we have to add is, of course, a chat model. And when I was scripting this video and basically creating all the workflows that I'm showing you today, I tried to work a lot with the Ollama models, for example, Llama 3.2. But what I found out is that the local hosted models are just not powerful enough to really understand the complexity behind MCP and using the correct tool. So until now, we have worked a lot with local models, and we will continue to do that. But for this time, I really advise you, I really encourage you to use one of the ChatGPT or maybe Anthropic models, because they are just so much more powerful than the locally hosted models, which are just not capable enough for working with the MCP server. So in this case, I'm going to remove Ollama, and I'm going to connect with the ChatGPT models. In this case, I've already configured my API key. If you do not have an API key yet, just navigate to platform.openai.com, click here on the gear icon, and then you see here API keys, and then you can create here your new API key, which you then have to provide to n8n. I'm going to use this one. I'm going to use GPT 4.1 mini. It doesn't really matter too much which model you use, as long as you do not use a local model. And then, of course, we're going to add memory. So click on memory. And in this case, I'm just going to select the simple memory. And let's increase the context window length a bit. Let's set it to 15 messages, because 5 is really not that much. And let's do it like this. And then I'm going to add a tool to the AI agent, which is, of course, going to be the MCP server. So click on tool, and then search for MCP. And the one that you need is this one, MCP client tool. So just click here. And then the only thing that it needs to know is the SSE endpoint. So navigate back to the server, click on MCP server trigger, production URL, copy this URL, and then just paste it right here at the SSE endpoint. For now, this is the entire flow that we are building. I'm later going to expand it with another MCP server, but first let's try if this part is working as expected. Before I do that, I still want to add a prompt to the AI agent, so click on the agent, click here on add options, and then we're going to provide a system message. And then let's try whether our setup is working as expected. You don't have to set the workflow to active, you only have to do that for the MCP server. So just click on save, and then let's start asking questions about the MCP protocol. Okay, so you see that we get back information which seems to be correct, but I also want to check whether the process of retrieving is correct. And you see here that, first of all, the agent is checking the simple memory, just checking if we already discussed something. Then it's redirecting the question to the chat model, and I see here that it's using the MCP client. So as you can see, it is sending the question, what is MCP? So this is the input, and then the output of the MCP server is this chunk of text. You can click here in order to expand it. Where the MCP protocol is explained. And you can just check whether the answer that you're getting from the AI agent is aligned with what the AI agent is receiving from the MCP server and the RAG database. And that seems to be the case in this case. Okay, so until now we have built an MCP server, retrieval augmented generation with a database. We have built an MCP client, but the AI agent still doesn't have any information about events, about MCP, for example, that happened yesterday or the day before yesterday. And in order to solve that issue, we're going to provide the AI agent access to another MCP server that has access to a search engine like Google. And now the difficult part of the AI agent that we are building today is letting it choose between the RAG MCP server and the MCP server that has access to the search engine where it can get information about current events. Okay, so everything that we have done until now, we could do both on the self-hosted version of n8n that is running on your local computer or on the cloud-hosted version of n8n. Now, the next part of this video you can only follow if you have the self-hosted version of n8n, and let me show you why. So for the next part of this video, we're going to need a community node. And I'm going to show you how you can activate community nodes on the local version. If you are on the cloud-hosted version of n8n, I'm also going to show you that. You can navigate to your name, to settings, and then you see here community nodes. And then you will see that you can install community nodes directly in your workflow. But if I go back to my workflow, and in my workflow, I can use some community nodes. For example, I can use the Brigt Data community node. If I click on it, I can just click on install node, but I cannot install the MCP community node. Now, if I click here on tool, I can use the MCP tool, but this is only the MCP tool that only supports SSE endpoints. So it does not support an STD.io MCP server, and that is exactly the server that we're going to use in this part of the video. So to summarize it, you cannot use it in the cloud, but you can use it locally. Now, if you want to use the STD.io MCP server on the self-hosted version of n8n, you can do that, but you just have to follow some configuration steps. And the first thing that you have to do is navigate to the link in the description to this workflow. And then you will find here this command, which is n8n community packages allow tool usage is true. So just copy this one, navigate to Docker, then click on the n8n container in Docker, navigate to execute, and then you're just going to paste this command right here like this and press enter. And this will allow the use of community packages in the self-hosted version of n8n. So if it's not working, just make sure that you stop your container and you start it again, and then it should be working. And then the next step, if you want to use this MCP server, is to install Node.js. So just navigate to nodejs.org, then click here on download, and just download and install a version for your operating system like this. Then we're going to navigate back to n8n, click on your name, navigate to settings, and then you will see here community nodes. And just click here on install community nodes, and then you're going to provide this server n8n-nodes-mcp. You understand the risks, and you're going to click on install. And if you've done all of this, navigate back to your MCP client, this one, tools. And if you now search on MCP, you do not only see like the official MCP server, which is only supporting SSE, but you also see the community node MCP server. And if you click on this one, I'm just going to add it to my workflow. And if you click here on create new credential, then you will see that this MCP server supports SSE, just like the standard SSE activity. It supports HTTP streamable, and it also supports a command line MCP server, and that is exactly the server that we need. So the way that this STD.io MCP server works is actually really simple. You're just going to use your console, your command prompt, and there it's going to execute commands. So it's going to start with the command npx, which is referring to Node.js, and then it needs to know the Node.js package, which is in this case Brigt Data /MCP. And if I now press enter, because I didn't provide an API key, it's going to throw an error and say, cannot run MCP server without API token env. So this MCP server is actually a Node.js package running on your own system. So how is it then able to connect to a search engine? So the Node.js package running locally on your system is referring to all kinds of APIs on the Brigt Data servers, and these are actually serving the data. So now we have seen how this works. Let's configure the server. So the first command is npx because we want to execute a Node.js package. And the Node.js package that we want to execute is this one, is Brigt Data MCP. And for the last argument, we have to get a Brigt Data API key. And for the last part, we have to get a Brigt Data API key. Now, Brigt Data has been a long-term friend of this channel, and they have been so kind to provide a coupon which provides you $15 of free Brigt Data credits. Now, you don't need anything in order to get this free credit. You don't need a credit card or anything else. So just click on the link in the description of this video to redeem your $15 of credit. And once you've clicked on this link and created an account, you're going to land on this page. We're going to click on proxies and scraping, add, and we're going to create a new unlocker API. And make sure that the name of the zone has to be MCP_unlocker like this. You see that I already have a zone like this. As soon as you've entered this zone name, you can click here on the add key. I already have a zone like this. And then we're going to navigate to account settings. And here you should either see an API key or not. If you don't see it, you can just click here on new user. If you already see it, you click here on the 3 dots and click on copy key. And this is the API key that we're then going to provide to n8n. And once you have your API key, you're going to navigate to this field. I'm just going to put it on expression so it's visible. And then provide here API token is equal to, then your API key. And then you can just put this to fixed in order to save it and click on save. Now the first thing that we need to be able to do with our MCP server is list tools. And this will provide our AI agent a list with all the tools that is able to execute on this server and their specific inputs, etc. So just make sure that this is list tools. Then let's navigate back. And then I'm also going to give this MCP client a different name. And then I'm also going to give this node a different name. And let's call it MCP Search List Tools, like this. And then we're also going to create a second node connecting to the same MCP server where it can actually execute the tools as soon as it received the list. So let's click here on the plus icon, search for MCP again. This is the one you need. Add it to the workflow, and then we don't have to connect again. The tools description, I'm going to set it automatically, but here the operation is not going to be list tools, but it's going to be execute tool. And the tool that we want to execute is Search Engine, like this. And I'm going to ask the AI agent to fill in the parameters itself because it has access to the list tools functions, so it should be able to figure out the parameters. Then let's navigate back. Let's do it like this. Let's add some colors here. So this is our RAG MCP server. Let's copy it. So let's make this one red, like this. And let's make this one blue. Okay, so now we have one MCP server, which is a RAG MCP. So we're going to use this for more knowledge that doesn't change that often about the MCP protocol. And the Search Engine MCP server, we're going to use this server in order to connect to a search engine so that we can get answers to questions about information that changes overnight. And let's also give this node a more descriptive name. So let's call this one RAG MCP server, like this. And then the most important part of this agent is to provide a prompt which allows the agent to choose when it has to use which server. So let's open our AI agent. We already have a prompt here, so I'm just going to change it. Okay, let's save our flow and let's give it a try then. So let's start with a very general question that it should be able to answer using the RAG server. You see, in this case, it is using the RAG MCP server, so that is very good. And it's providing us an explanation about what the MCP protocol actually is. Now I'm going to ask a second question, which is about more current events, to also see if it's able to use the Search Engine MCP server. And in this case, you see that it starts using the Search Engine MCP server. It didn't use the list tools tool. It actually used the Search Engine MCP server, and it provides us a list with all the latest developments about the MCP protocol. I'm really curious which MCP server you built while watching this video. Please let me know that in the comments. And if this video was helpful for you, please don't forget to give it a thumbs up and subscribe to my channel if you want to see more videos like this.